Exploring periodic data. So the first thing we need to do is start with our vocabulary. A periodic function. It's a function that repeats a pattern of y values. So we're going to go ahead and fill that in. A function that repeats a pattern of y values. Okay, so, and don't forget that your y values are the range of the y values. The range of the function is repeated. So another way to think about that, because sometimes students really struggle with what that means, so another way to think about that is that the function rises and falls, the same amount from left to right infinitely. Okay? It rises and falls by the same amount, so it's always going up and down by the same amount, left to right, infinitely, so in both directions forever and ever. Okay? A cycle, so this is a part of the periodic function. A cycle is one complete pattern. So in other words, remember that the function is a pattern that repeats over and over and over. So up and down, up and down, up, over and over. So this is one complete section, and then it starts to repeat again. The period of the function is the horizontal length of one cycle. So left to right, beginning to end, what is the length of one cycle? Okay, so horizontal, remember that horizontal means left to right. Horizontal, left to right, length of one cycle. There we go. One cycle. All right, so we're going to use these examples to help us kind of identify that on a graph. So let's look at example 1. And these were screenshotted from some different resources, so they may not be super clear, and I apologize for them being a little bit blurry. Number 1 says, identifying cycles and periods. So analyze this periodic function, identify one cycle in 2 different ways, then determine the period of the function. So off to the right-hand side, it kind of tells you what we're supposed to be doing. So begin at any point on the graph and trace one complete pattern. So I'm going to do this for you in a color. So I'm going to start here at this point. And now my graph goes to the right, up, across to the right, down, to the right, up. And now I'm right back where I started, because now I'm going to go to the right and to the right. So you can see that this one is going to look exactly the same as the last one. It will keep going, and then it would come up to here, and it would end. So this is the repeating pattern. Okay? You might have started in a different spot, but you just have to make sure that you figure out where it starts to repeat itself over again. So begin at any point on the graph, trace a complete pattern. The beginning and ending x values of each cycle determine the period. Beginning and ending x values determine the period of the function. Okay? So the period is the distance from length of length. So from here to here, this is the period of the function. Okay? Each cycle is how many units long. So if we counted, these look like, if we look at the graph, 0, so we're going to have 1 unit. This is -2, right? So each unit is worth 1. We can tell that based on our picture. So I'm going to look at 1 unit, 2 units, 3, 4, 5, 6, 7. So the cycle, or the period, is 7 units long. Each cycle is 7 units long, therefore the period of the function is 7 units. Okay? So I'm going to scroll the page up so we can go ahead and look at example 2. So let's do that. So looking at example 2, it says determine whether the function is or is not periodic. If it is, find the period. So I'm going to look at this function and decide, does it seem to repeat itself over and over and over? And if so, is it rising and falling by the same amount? So if we look at these two marks on the graph, it never goes above or below that, and the pattern in between them is the same. It rises and falls by the same amount all the way through, and it definitely repeats. If we start here and we trace the function, right, it starts to repeat right here, and it will do the same thing over and over again. So the pattern of y values in one section repeats. So the pattern of y values in one section repeats exactly in the other section. The function is periodic. Okay? Find points at the beginning and end of one cycle. Subtract the x values. So now what they're just saying here is they want you to find the period of the function. Okay? So you're going to start and you're going to subtract to find the difference. So it says to points beginning and end. So here they are, 4, 0. And 0, 0. Those are my 2 points. Okay? And it says to subtract the x values. So I'm going to do 4 subtract 0, and it's going to give me 4 units. So the pattern of the graph repeats 4 units, so the period is 4. Okay? Distance from left to right. Now I'm going to identify the amplitude. So the amplitude is different. The period is left to right. Okay, period is left to right, but the amplitude is up and down. So highest point to its lowest point. Okay, so how much is it rising and falling? Amplitude of a periodic function. The amplitude of a periodic function is half the difference between the maximum point and the minimum point. Between the maximum point and the minimum point. So we're going to look at this function, and what you need to remember here, the important part is it's half the distance between the maximum and the minimum, because every function has sort of a middle ground where you can kind of draw a dashed line, and you can see that that dashed line is drawn in this function. Here's your dashed line, okay, and your function, if I choose a spot and repeat over and over, so here's the function, it's going to go down here, and then it's going to come back up, and you can see that it's got this little dip, and then we're right back to where we started, where it's going to drop way down again. So this is the pattern that keeps repeating. Okay, that's the cycle. And so the question is, highest point to lowest point. So here I am, and here I am. So I'm between this. You'll notice that red dotted line cuts that section right in half, okay? So the highest point, if we look at our y value, here's my y-axis, okay, and here's my x-axis. So this is 0, 0 right here. So I'm going up 1, 2, 3. So this is 3 on the y, and then I'm down here at -1 on the y. So I have to figure out how many units are between that, okay? How many units are between that? So -3, you're going to take the difference between the maximum and the minimum. So we have 3 minus -1, which is 3 plus 1. So 4 units. Okay, 4 units high. You can agree. 1, 2, 3, 4 units high. And so the amplitude of the function is 2. It is 2 above center and 2 below center. So the amplitude is 2. You have to take this number of units and you have to divide it by 2. And that gives you the distance above and below that middle. That is your amplitude, okay? So we're going to go to the next page, and we're just going to very quickly do a couple of sample problems before you do the next page in your packet, which will be your in-class practice. So let's go and do a couple more examples here, just to make sure you have it. So we're going to go ahead and look at the second page. And unfortunately, we refer to an example in the book here, and your book is online if you need it, but we don't necessarily use it. So most of what we do is in class, so we have the books here for us if we need them. But if you were looking in the book, this would actually be example 3, and it's on page 712, if you wanted to refer to the book when you come into the class. So basically, the amplitude of that picture is 1/2. The amplitude of any picture is 1/2 the maximum value minus the minimum value. And so if you look at the picture in the book, the maximum is 4 and the minimum is 2. And remember, we have to take the difference and then do 1/2 of that. Okay? So you substitute the maximum here and you substitute the minimum here. Okay? And remember, order of operations says that you need to do this part first. So 4 minus 2 is definitely not 3. Sorry about that. I'm working ahead of myself. 4 minus 2 is 2. Okay? No, excuse me. Let me fix that. It's really hard to read. It's 4 minus -2. I didn't copy this right. Go up here, please, and put a -2 in here. 4 minus -2. I chose this example because you are subtracting a negative, and I want you to be really careful about subtracting a negative. That's why I chose this example. So I have 4 minus -2, so that means 4 plus 2. When you subtract a negative, you're truly adding. 4 plus 2 is 6, and then we have to take 1/2 of 6. That's where my 3 came in. I was reading ahead. Sorry about that. 1/2 of 6 equals 3. So the amplitude of the function is 3. So on my y-axis, just to give you a little perspective, right, I have 4, 3, 2, 1, 0, -1, -2. So I'm saying the maximum point was here at 4, and the minimum was here at -2. And remember that halfway is that little dashed line, right? So this is telling me 3 above and 3 below. So I would do 1, 2, 3. Right? And then here I would do 1, 2, 3. So this would be the halfway point. My function would rise and fall, and that would be sort of the middle line of my function. Okay? So there would be 3 above and 3 below, so that's your amplitude. All right, so now let's do these quick check problems. Let's do 1 and 2, and then we'll move on after that. For the function below, identify one cycle in 2 different ways, then determine the period of the function. So remember, period means left to right. So I'm just going to do the 2 easiest ones. It says to do it in 2 different ways. I'm going to start here, right on the x-axis, and then it goes up, and it goes down, and it meets the x-axis, and that's where it would begin to go up and down again. So that's one way to represent it. Another way is to start up here at the top of the function and go down and then back up at the top, and then you would start over again, up and down. So you can see those look very different, but they're going to represent the same distance left to right. So if I count in red my beginning point here, I'm going to go 1 unit, 2 units, 3 units, 4 units. So I get 4 units left to right, and then I can double check it using blue. 1 unit, 2 units, 3 units, 4 units. So again, 4 is the period of the function. Okay, so this was a period question. Number 2, determine whether the function is or is not periodic. If it is, find the period. I will say yes, that it is periodic because it rises and falls by the same amount all the way through and seems to have a repeating pattern. So yes, it is periodic. And now I need to actually find the period. So again, it doesn't matter where you start and stop. It's certainly up to you however you do it. I'm going to start here at the highest point on my function because it's going to be easy to know when I'm at the highest point of my function again. So if you choose the highest point as your start point, then it's easy to know when you've ended the period and you're back to where you started, right? So I'm going to go down, and then I'm going to go up. So now I'm going to just have to repeat that over and over, and I'm going to look at how far that distance is. 1 unit, 2 units, 3 units, 4 units. So the period of this one is 4 as well, okay? So again, that was a period question. 3 and 4 are both dealing with amplitude. So if we just review period a little bit, and now let's review the 2 amplitude problems. So I'm going to start with number 3, find the amplitude of the function. So remember, you do this. So the highest point on my y, if this is my x, this is 0, 0. Okay, so you always should find that middle ground first when you start looking for what your digits are on your y's and x's, because sometimes they're really hard to find on there, and they don't always go by 1s. Some graphs will go by 2s, and some will go by 4s. So you have to find your 0, 0, and then decide what each unit, each mark is worth. So if I look here, 1, 2, so they're going by 1s. So this is 1, positive 1, okay? And then if I go down, that's 1, 2, so this is negative 2. And so remember, I have to figure out the distance between those two, and then I have to kind of draw my dotted line, right? So I have to do the maximum minus the minimum, and then take 1/2 of that, or divide it by 2. So 1 minus negative 2 divided by 2, or 1 plus 2 divided by 2. So that's 3 over 2, which is about 1 1/2. So I'm going to come down 1 1/2 boxes from the top and 1 1/2 boxes from the bottom, and that is my amplitude, 1 1/2, or 3 over 2. Okay? Number 4 is asking us to do something, and this is challenging. This is a very challenging question. They want us to sketch the graph of a sound wave with a period of 3, so left to right, 3 units long, and an amplitude of 2. So 2 above and 2 below, 3 units long. So the first thing we're going to do is let's go ahead and put our y-axis, and let's put our x-axis. Okay? And then think about what it's asking us. It wants us to go 2 above and 2 below. So the first thing I want to do is go 2 above and draw my dotted line, and go 2 below. That is where I need to keep my function rising and falling in between those, okay? So 2 above and 2 below, that's your amplitude, okay? And then the wave is going to be 3 units long. So I'm going to go here, and I'm going to say 1 unit, 2 units. So it's going to repeat here. This is the section that it has to repeat between. And so I'm going to just make this very easy for myself. I'm going to mark the halfway point between those 3 units, and I'm going to start right up here, and I'm going to come down, and then, oops, sorry, my markers are kind of big. So I'm going to mark the halfway, right? And then I'm going to come down and back up, or start here is what I should say. Beginning and end, right? And it has to cross in the middle. So this half is going to be where I go up to the top, and then I'm going to cross right there in the middle, and then this is where I'm going to go down to the bottom. So I kind of make this loopy picture, and it's 3 units wide, right? 3 units left to right, and amplitude up 2 and down 2. Now you could choose to stretch that out if you wanted to and make it longer, or you could have just made the 3 units just kind of go down and then start to repeat, whatever you want to do. Just remember that wherever you start, you have to end up in that exact same spot. So for me, it's easy to do beginning and end, and then have a middle point where I have to cross it over. And then I go up to the top, I cross at the middle point, go down to the bottom, and then I'm right back where I started. That just, for me, makes sense. You certainly have options to do it differently if you'd like to. So that is essentially just section 1, which is just all about reading a periodic graph. Is it periodic? What's the length left to right? What's the period? And what's the amplitude? How high or how low does that function actually go? Okay? So you can go ahead and move on to section 2 when you're ready.